and welcome to Mathematics Made Easier channel. This is your online mathematics tutor, Comfort Amwakon Ata. Today, I'm going to take you through on how to derive the various circle theorems. Before me is a circular cutout which has been designed. And today's lesson is promising to be very interesting. So relax and go through with me. Okay, so before we come to the various theorems, we will quickly go through the parts of a circle. This is our circle with a center at this point. Then a line from one point of the circle to the other becomes our chord. Okay, so this is a chord. If I move this chord up to the center, it becomes our diameter. Then the region bounded by the chord becomes my segment. So this, if I have the chord at this point, this becomes my minor segment, and the whole of this part becomes my major segment. This is my arc. This becomes my minor arc, and this side too becomes my major arc. So, if we are done with that, we will now look at the circumference, so the distance around the circle. We call it the circumference of a circle. Okay, so a line from one point, a line from the center of a circle to any part of a circle becomes our radius. So this becomes our radius. This side too becomes our radius. From the center to any part of a circle, the circumference of a circle becomes our radius. So in conclusion, we can say that 2 radii forms a diameter. Perfect. Knowing the part of a circle, let's now prove 1 or 2, the first and the second theorem. So in this case, a line from one part of a circle, okay. Knowing the part of a circle, let's now prove the theorems of circle. As we said earlier on, a line from one point of a circle to the other points of a circle becomes our chord. So this is our chord. If we extend this chord to the center, there's an angle forming at this side. Now, let's now extend the chord from the center of the circle to the circumference of the circle. So we are having something like this. And an angle is also forming at this side. So we can say that, now let's measure the angle forming at the center by the chord. And the angle also forming at the circumference by the same chord. Let's measure it together. We pick our cutout sheets, then we fix it here. Okay. Then we cut it out. Okay, let's fix it here and see whether it's going to fit. Perfect. Good. Now, we are going to fold this angle into 2 equal parts. Then, fix it at the angle at the circumference of a circle. Great, it is also fitting. So we can, based on what we've been able to derive, we can say that the angle a chord subtends at the center of a circle is twice the angle it subtends at the circumference of the circle. And this is our first theorem. Excellent. Let's prove another one. By extending my line from the chord to the center of the circle becomes my diameter, as I said earlier on. So this is my diameter passing through the center of my circle. Okay? Then I extend this angle to the circumference of the circle. An angle will be formed at the side. Let's now measure the angle forming at the side and see. So that one too, I'll pick my rectangular cutout. I believe you know that a rectangle has a total sum of what? 360 degrees. So each angle forms 90 degrees. So fitting this one here, let's see, and it is fitting exactly. So the angle subtended by a diameter to the circumference of a circle is 90 degrees. Regardless of where your shape is, you should still get your 90 degrees, provided it is coming from the diameter of your circle. Please take note. Thank you so much for your time. In our next video, we are going to look at practical ways in learning prisms and pyramids. And it's promising to be very interesting as well. We make mathematics so simple and practical. So I encourage you subscribe to my channel and click on the notification bell for updates. So we meet again. Please stay safe and learn hard. Bye.